So I don't know if you could hear that or not, but it's a beautiful morning here at Rideau High School in Elgin. The birds are chirping. It's starting to feel more like spring again. So here we go. The crazy screen here, right? Infinite little windows of going into windows. Anyways, here we go. Vertical shifts of quadratics. All right, so we're going to be shifting quadratics up and down. And so same deal as before. I want you to think about what the equation would be to match that. So I have a y equals x squared here. That is the standard graph that we know and love. And you can tell that it's been moved up 3 steps. So that's sort of like we did before, a key step, key point to sort of look for. See, like, oh, look at that. We've got a 1, 3. We were at a 0, 3. And we were at 0, 0. And so you can tell this one has been shifted up 3 steps, right? Very obviously. And then the 4 has also been moved up 3 steps. Oh boy. Said 4, so then I wrote 4. Up 3 as well, and up 3 as well. So you can tell what's happened there. I've restricted this graph so that it really does look like it's shifted up 3 steps everywhere. So I just went from the -2 to 2 so you can see it. When you graph with GeoGebra, it's going to look more like that, which still has the shift up 3, but people get kind of messed up by this little decreasing space between, and that's just because of the way the quadratic shapes look when they're side by side. All right, so maybe press pause and go to GeoGebra and so on. I'll go to GeoGebra actually here so you can get a refresher on how to do that. So type in GeoGebra graphing calculator. My computer still knows me well here. So here we go. So you graph like the regular x squared. So just x power of 2, however you want to do it. The other way of doing power of 2 with the program would be to hit this and then do power of 2. Okay, so the bottom corner access thing there, it's like a sort of a little keyboard. Okay, so there's your x squared. And so then we're looking for another quadratic that's going to be like that one, but shifted up 3 steps everywhere. Press pause, give it a try, come back and see me. So hopefully you're back now, and we have x, and then we're saying power of 2. Oops, I forgot to do the x. That was a time symbol there, so I need to do x right there. Back there, where we go. So x, power of 2. And then, as we said, we want to have like all the spots like shifted up by 3, right? And when I drew it on the page here, even I was saying like +3, right? So I think it should be pretty easy to guess that if we take all those y values, which is what x squared is, and we're adding 3 to all of them, shouldn't be too much of a surprise in the end here, or too hard to guess. Where's my enter? There it is. Yeah, there we go. Right, so that is what we get. Okay, so the answer, if you managed to guess it, great job. The answer is, of course, that we have this +3 on the end for that equation for it to make that picture. Oh boy. Back here. All right, so that number, we're adding on to the x squared, which is, really, like I said a second ago, what the y value is, right? Y is x squared. So when we're adding 3 to all of them, we're adding 3 to all the y values. We're adding 3 to all the heights. So it does exactly what we wanted. Okay, so the summary of that, well, at least to start out with, part of the summary is that we have this k, this letter, this number, sorry, out in the end, but we represent it with a letter so that it can be any value you want. It doesn't matter what letter you choose. Some textbooks have a K, some have a Q. It doesn't matter at all. It's where the number is that matters. Okay. So let's go back and do some examples, and then we'll finish that summary. So this one here, the actual details to produce this digital version of that graph is you would graph your normal quadratic, so your excuse me, your -2 to 2 going 4, 1, 0, 1, 4. So there's your 0, 0, your 1, 1, minus 1, 1, 2, 4, and minus 2, 4, and that's all I'm going to graph for this one because I don't have a 10 by 10 scale. Can't go all the way up to 9. A little bit lopsided, but you know, yeah, I don't want to redo the whole thing, so good enough, right? So that right there, if we did it on the graphs first, it'd be pretty easy where we're literally just going to shift each spot up by 3, right? So this spot goes up by 3, this spot goes up by 3. You get a car, you get, yeah, sorry, you know, there we go. So there's your spots. I don't know if you ever watched the Oprah Winfrey show, or at least clips of it. Anyways, here we go. So there's the up 3 version. So you can label this thing as like y equals x squared plus 3. And of course, the green one was the y equals x squared. Okay, so there's another example. Previous lesson, I was doing the from the graph as an afterthought. Here, I'm just doing it as the main way because it's so easy. Okay, works nice. Now, to be able to do it with math, of course, is good as well. So let's do that as well, right? We're just have each of the y values have a 3 added to it, right? So this one gets a 3 added to it. This one gets a 3 added, and so on. And I won't bother to write all of those. But of course, 4 with a 3 added to it gives a 7, and 1 adds a 4, 3 you get 4, and 0 adds a 3 you get a 3, and so on. Okay? So all of those points are on this graph. Like if you look at the 0, 3, there it is, right? Matching the blue to the table there. And the 1, we have at 4, there it is. Or at least close, right? My drawing was off a bit with the points there, and so on, right? So each of these spots would have been what we would have graphed point by point. And it matches our logic of just shifting everything up by 3 as well. Here we go. So that one's done. There's a blank page there for you to work from, of course, as usual, if you'd like to actively go about this. And so here, what about this one? So we could do this one, table first if we wanted. Each value, of course, is going to have this 4 subtracted from it. Right? So if we have a 4 subtracted from each spot, then we're going to subtract 4 and get 0. And then we're going to subtract 4 and get -3, and so on and so on. Okay? So ditto, ditto, ditto all the way along here, right? So subtracting 4 gives you -4, gives you the -3 again, and gives you the 0 again. So we can go ahead and graph just the blue one, really, if we wanted to. But typically we would have graphed the original first as well, which goes on lickety split, as they might say, if they're weird like me. So y equals x squared, and there you go. So with the graphing here, we have our 0 and our -4 point on, our 1 and -3. So sorry about that. It's a point at over 1 and down 3, and our 2, 0, and our -1, -3, and our -2, 0. So again, just plotted from the points. So that would work, no problem. If we graphed that, okay, great. There's the graph that's been shifted down 4 steps. Working backwards here to say, okay, could we have done that right from the graph? Of course we could have. Not like that, though. Actually, I didn't mean to do that, but literally shift the thing down 4 steps, right, is what we need to do. So I'll just undo that and put it there, but show the idea. What I meant to do here was drawing down 4 steps, down 4 steps, and down 4 steps, right? Down 4 steps and down 4 steps. It shows great understanding if you show, those transformations like that. Again, the graph in the end, it gets a little messier looking, but what's nice to do is sort of emphasize this result. So you're showing as a student that you're confident what your answer is, and all the rest is there to support your understanding of it and how you know. Okay, so that's kind of what I want the graphs to look like in the end, where you have the original and you have what transformation made it happen, and you have the one that you're confident is the final result. So label it and everything. Sort of more bold or obvious that that's the one. Okay. Yeah. So that now this that's just this is the generic one. I have this page on here, but basically the idea is you can this helps get the idea of the negatives as well. So let's do this one a little bit. So there's your regular graph, regular basic quadratic graph. Fussy. That. Right, so there's your y equals x squared. And then the idea I want to get across here is that you could go up or down by k. So up a positive k or down a negative k. So shift this thing up like this to here, and you get a graph. So on. I'll just do a little bit of it here. Right? Or we could go down. So let's down with blue maybe here. Color code things a bit. So that's supposed to be a k value, but we can go to any number we want, right? We could go, 5 if we wanted to, even so down 5 on the graph, but down k, whatever number you want, right? And so each one of those would have been down the same amount, giving you that same shape, right? And then same deal here, but there's really not much to show there other than you're just adding k. I can say adding k. Because if k is a negative value, it's down and so on, right? So basically we're adding k to each one. And the value of k itself determines whether it's up or down. So the end result here, we've got, we looked at it a second ago here. If k is greater than 0, in other words, k is positive. And we know that it would translate vertically which way? It would go up, right? So if k is positive, it's going to go up, size here. And if k is negative, so I'll go with red here. So k is a negative value, and of course it's going to go down, right? There it is, down. And then if k equals 0, well, what would happen then? If k was 0, think about your equation. Y equals x squared plus 0 is just the same as x squared, right? So it's kind of silly to even state that one, but textbooks are silly sometimes. So that one, it would just be the regular graph. There's this is the graph as one intercept is kind of a different concept that we're talking about, I guess. But I guess if they're talking about the graph having one intercept right there, then they should probably also be mentioning that this one has no intercepts, right? So this one has one x-intercept or solution or root or 0. And then this one has up here, you can tell there's no x-intercepts. Solutions, roots, or 0s. And then this one has 2. Right? So this one has this one and this one. It's 2 x-intercepts. That's kind of an additional thing to think about that people wouldn't necessarily go there at this point. But good to make that connection, I suppose. Right? But do it for all 3 if you're going to talk about it. Anyways, so there we go. And then the idea now is we can do the 2 that we've already talked about, one after the other. Okay, so this is more than one transformation. So the first transformation happens on the original, talking about it up here now. The second transformation happens on the result from the first transformation. Okay, so we have our original, the regular quadratic that we just write down without a lot of calculations or thought, I'm hoping. I should have had the -2, -1, 0, 1, and 2 in each of these. That's not any different at this point. I suppose that's going to be something to know that they're not different though soon. So yeah, I'll leave them blank for the next one as well. So the green one, we'll graph it like normal. Make sure you're practicing this enough that you get to the point where you can do that as easy as that. And then this one here, the y values, remember this one, the review from yesterday or last lesson, was that the y values are getting multiplied by -1. So I don't really need the brackets there either, but let's do this. So times a -1, and so -4 and -1 and 0 and -1 and -4. So I can graph that one. So the 0, 0 stays put, and this becomes a -4, -1 and -4 and so on, just upside down. So that's the first one. And then for this one, we are moving everything down 4 steps, right? So let's go with purple color, match that equation. And so we're going to be subtracting 4. So that's going to give us a 0. Subtracting 4 is going to give us a -5. Subtracting 4 gives us a -4, and so on. Oh, -4 subtract 4 gives, on the first one, noticing the lack of logic here for where the numbers would be, it's going to be a -8. Right? You had a -4, and then subtract another 4 from it. We're down 4, and then down another 4. For a grand total of down 8. So then down 4 from this one, down at -5, and down 4 from that, down at -8. Okay, so we can graph part of this one at least, and then I can extend the graph and show a bit, page and show a bit more. But our 0 point gets moved to be 0, -4. So you have to make sure to look at the x and the y now for the purple one, right? So it's 0 and -4. So there it is. It's been shifted down 4 steps. There's the graph version of things. And down 4 steps. So there's that. Maybe don't do the arrow for all of them. It gets a little messy. And then down 4. So down another 1, 2, 3, right? Past the original 1. So we're down 1, 2, 3, 4 total. And you see your purple one being the one that is y equals -4x squared, and then also a minus, oh, sorry, that's not right. It's -x squared, not -4x squared, because it's not, the shape wasn't changed. But it was moved down 4. All right, so that's it. That's what we need to be able to do. Your practice assignments up here, as usual at the beginning. Some of these are just match the graph with the equation, right? And maybe give a little bit of a justify, right? And so I'm going to say and explain, right? How you know or why or whatever. Just short and brief, but just explain a little bit. This one's quick too. The one where there's a little bit of work to do is the last question here. So only 4 of them to practice. So, okay. There you go. There is additional practice stuff down here if you want to do them, but they're not required. All right, that's saved, and I will sign off. Post questions if you need help. Talk to you later.